Good morning, dear students. Hope so you are fine and enjoying these digital classes. Dear students, welcome to this chemistry period. This is class +1 and we are doing unit 2, structure of atom. So welcome to digital classes. समय 10 से 12 वाला हर घर बनी पाठशाला. Today on 11th May, I'm going to tell you about this brief map minding of this chapter, whatever we have done last week. So the name of this chapter is structure of atom. So we are discussing about the atom here. So the basic history of atom starts from the Democritus. Democritus' contribution is he coined the word atom at first time in 460 BC. Then after that, after so many years, John Dalton was the first scientist whose contribution is the remarkable contribution in chemistry field. In 1808, he has given atomic theory, in which he told first atom is the basic unit of all the matters. Then after that, the basic structure of atom discussed in the three basic way. First is electric nature, second is wave nature, and third is particle nature. So one by one we will discuss. First, let's discuss the electric nature of matter. Electric nature, this thing you know very well. In electricity, the electric current is due to electrons. So it means that there is electrons inside the atom. Okay, so at first Newton has taken this. According to Newton, the light is one of the electric nature of the matter. Light is a matter in which the electrons are there. Okay, but Michael Faraday in 1830 he established a relationship between electricity and matter. He was the first scientist who find out the relationship between electricity and matter. He told electricity is a kind of matter. So after this, J.J. Stoney 1874 he suggested that the name of electron for atom. He first suggested the electricity is not because of atom, it is because of electrons. Okay, so dear students, it is like students in this particular video I am telling you the relationship with the beautiful these small increasing order of the dates, with the dates, the contribution that the scientist has done as per the time how the atom structure is developed. That history we are discussing. So as we have told you, J.J. Stoney's contribution. After that, William Crookes in 1879, after 5 years, he has find out that the conduction of electricity through gases at low pressure. He found that with the help of that discharge tube experiment, at low pressure the gases are conducting electricity. Okay, after that his contribution was taken by J.J. Thomson. So J.J. Thomson discovered electron with the discharge tube experiment in 1897. So second, E. Goldstein in 1886, he observed positively charged particle of proton with the same discharge tube. So he got this reward to discover the proton. So proton is discovered by E. Goldstein, electron was discovered by J.J. Thomson. So after this, Henry Becquerel in 1896 he discovered radioactive radiations, in which he found that alpha, beta, gamma are the three basic rays. Okay, so J.J. Thomson's model of an atom in 1898 he has given us a proposed model which relate with the Plum-Pudding and water molecule model, in which he told electrons are embedded inside and protons are around the electrons. Okay, but the best thing was there. He told number of electrons is equal to number of proton. In this way the atom is a neutral atom. Okay, after that some of the limitations were there in the J.J. Thomson. So to remove those limitations, to overcome those limitations, Rutherford has given his scattering experiment. This is called gold foil experiment. In this he discovered that nucleus is the center, which is comprised by proton and neutron. The nucleus is the combination of proton and neutron, and electrons are revolving around the nucleus. Okay, and he has given the better model of an atom than the J.J. Thomson, but in his model also there were some drawbacks. So James Chadwick, side by side in 1932 he discovered the neutron with the bombarding of a thin foil of beryllium metal with the alpha particle. So he found that neutron also playing very important role. Although neutron doesn't have any charge, proton have positive charge, electron have negative charge, but without charging, neutron is playing very important role in mass number. So after all this story, we conclude that now atom is not the basic unit. There are some subatomic particles which are the smaller than atom. Okay, it is electron negatively charged, proton positively charged, and neutron no charge. Okay, so after this we come to know, once we know the electron, proton and neutron, then we come to know atomic number is what? Atomic number is number of proton. The number of proton in an atom is equal to the atomic number, and the sum of proton and neutron in the nucleus, that is making atomic mass. So this is up to this. There is electric nature that we have done. After that we started wave natures. This also we have done. So in wave nature of electromagnetic radiations, now we are using the word electromagnetic radiations. It means that the matter or the atom, all the matters, they are showing the wave nature also. Wave nature is that nature in which the electron are moving in wave like. Okay, electrons is move in a wave like, in which the wave have two properties, in which one property is electric property, second is magnetic property. As electric property and magnetic properties are perpendicular to each other, so in this basic properties we are discussing the matter is showing the wave nature, in which the magnetic field is perpendicular to electric field. Okay, if magnetic field are toward x-axis, so magnetic field is toward y-axis. So y and x-axis are two axes. So in this we have just discussed about the basic properties. And in wave nature, first scientist, that is C hyphen, he replaced the light by wave theory. He told the light is showing like a wave. And after this, James Clerk Maxwell, 1870, J.C. Maxwell, in his Maxwell theory, he stated that light, X-rays, gamma rays and heat all are electromagnetic waves. After this, electromagnetic spectrum, which we'll discuss in the future topic also, in which cosmic rays, gamma rays, X-rays, UV rays, visible rays, infrared rays, microwave, radio wave, all these rays are electromagnetic spectrum. Set of these rays make electromagnetic spectrum, in which specially we will discuss about the visible rays, in which visible range is Vibgyor, which is colorful rays, violet, indigo, blue, green, yellow, orange and red color, which is also known as rainbow. So after this, once the wave nature we know, wave properties we know, then the third type of nature of the electromagnetic radiation is particle nature. Now what is particle? Particle is those that property of matter in which matter is always continuously moving in the nature. So the first scientist, that is Max Planck, here particle nature is also known as in the simple way the Max theory. Max Planck in 1900, he given his Planck's quantum theory, in which the set of light in electromagnetic radiations made up of particles, in which he related that E is directly proportional to V, in which E is equal to h mu and hc upon lambda. So C upon lambda is mu, that is according to wave theory, and h value is 6.62 into 10 raised power minus 34 joules per second, or 3.99 into 10 raised power minus 13 kilojoule mole inverse. So E is becoming n is equal to h mu, where n is integer 0, 1, 2, 3. So this value we have discussed in the last video also. Once you if you are not remembering, so you go through that video also. But here particle nature is explained in two basic theories, basic definition, that is black body radiations and photoelectric effect. Here you need to relate, if any matter, whatever matter that on which the light is falling, so basically the black color that is absorbing all the lights, that is absorbing all light, and which is emitting light, that is emitting light is radiation is also in the black body. So black body radiation means a perfect absorber and a perfect emitter. All the body which is a perfect absorber and a perfect emitter of radiation, which means that it emit and absorb radiation of all frequency which fall in its surface, that is called black body radiation. So it is a property of matter. In the second, photoelectric effect, photo mean light, electric mean the electrons behavior. So photoelectric effect is observed by Hertz in 1887, in which he told the ejection of electron from the surface of metal under the influence of striking photon. It is very simple in our surrounding how we can see the color object. Suppose you can see here green, red, yellow, green, blue, all these color, how our eyes are able to see, that is because of ejection of electron from the surface of this body. Once the light is falling on the body, the more than threshold energy, when we are having more than threshold energy, it will eject the outermost, it will eject the electron from the outermost layer of the atom, which is forming the color. Okay, that is photoelectric effect. After this we will discuss in future in detail the electromagnetic spectrum. So this is all about for today's video. In this video we discussed about all the topics that we have done previous week. This is a kind of reminder and revision to you. So hope so you like this video. Keep watching these videos. Till next video, please take care, stay home, stay safe. Today in the next video also, same day I am sharing the next video, so please go through for the next topic next video. Okay, till then, take care, stay safe, stay happy. Okay, bye, thank you.